All right, so in this lesson, we're going to learn to prove lines parallel. Okay, so we do not know that the lines are parallel. So if you actually look at the picture, there are no arrows on this. So although it looks like they're parallel, technically it could be drawn like so, where they're not. So we're trying to use information about corresponding angles, alternate interior angles, alternate exterior angles, consecutive angles, to actually prove that the lines are in fact parallel. All right, so let's first look at our converse for corresponding angle converse. So I want you guys to notice we've got converse on all of these. Remember, that means we're switching the hypothesis and the conclusion for the theorems we learned yesterday, right? The theorem said if it's parallel, then these angles are congruent. Now it's saying if two lines are cut by a transversal so that the pair of corresponding angles are congruent, then the lines are parallel. So every one of these are ending with the conclusion, then the lines are parallel. Right? Literally every single one of these converses say, then the lines are parallel. All right, so looking at our first one, we've got the corresponding angle converse. It says if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So that would mean corresponding angles. So we would have if angle 1 is congruent to angle 5, because those are corresponding angles, then L is parallel to M. Okay? Alternate interior angles converse says if two lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the lines are parallel. So if we look at the picture, alternate interior angles are 4 and 6. So we would have to have if angle 4 is congruent to angle 6, then L would be parallel to M. Alternate exterior angles converse. So if you look for a pair of alternate exterior angles, we would need 2 and 8 to be congruent, or 1 and 7, right? But I'm looking at the example specifically for 2 and 8. So if angle 2 is congruent to angle 8, then L is parallel to M. And then we have the consecutive interior angles converse. Remember C to C? These angles. So these are definitely not congruent, right? One's acute, the other one's obtuse. So that converse says if two lines are cut by a transversal so that the pair of consecutive interior angles are supplementary, right? They have to add to 180. So we would write down if the measure of angle 3 plus the measure of angle 6 equals 180, then L is parallel to M. Okay? And then we have the consecutive exterior angles, which we really didn't use, so you can just cross that off. All right, so you have to have those relationships in order to prove that they're parallel. So you use converse to prove parallel lines, at least for these specific theorems. All right, so looking at these examples, it says for each below, determine whether there is enough information given to prove that they're parallel. Explain, which means state which converse is used. So if we look at 1, we have two angles that are 63 degrees, and they happen to be what type of angles? Alternate exterior angles. So we can say, yes, L is parallel to M using the alternate exterior angle converse. And we can abbreviate converse CONV. All right, looking at number 2. Looking at this, we have two congruent angles, right? Just one arc on both of these angles is telling us that those two are congruent. So are the lines parallel? Well, what type of angles are those? Those are corresponding. So we can say, yes, L is parallel to M using the corresponding angle converse. If you were to write theorem for this, that would be wrong, because we're proving that they're parallel because those two angles are equal. All right, looking at number 3, we do not have a name for these types of angles. But if I use the linear pair postulate to get this angle, so 180 minus 48 is 132. Now, do we have a type of angles that are equal? Well, yeah, these two are both 132, and they happen to be what type of angles? Corresponding. So we can say yes, L is parallel to M using the corresponding angle converse. All right, number 4. These angles are both 105. What kind of angles are they? Vertical angle theorem. Does vertical angle theorem prove lines are parallel? If you look back up at all of your converses, did any of them say, if you have vertical angles, then the lines are parallel? No, it's not there at all. So vertical angles do not prove lines are parallel. So you would say no. Vertical angle theorem does not prove parallel lines. All right, number 5. What kind of angles are these? Well, again, remember the arc shows that they're congruent. So those two angles are congruent. They happen to be alternate interior angles. And if alternate interior angles are equal, then the lines are parallel. So you should say yes, L is parallel to M using the alternate interior angle converse, right? Because they're inside of these two lines, so they're inside. So, and they're on alternate sides of our transversal. All right, number 6. So looking at these, they are not equal. If you look, it's a backward C. Do you see the C? So consecutive angles have to add to 180. Is 125 plus 65 180? Is it? It is not, right? So we're going to say no. Consecutive angles are not supplementary. All right, so let's try some examples with algebra. This is the same idea that we did yesterday. Okay, so it says, find the value of x that makes them parallel. So we're assuming that we're making them parallel, that they are actually going to be parallel to each other in each of these. So if these two lines are parallel, these two angles have to be equal because they're alternate exterior angles. So we just need to make 2 parentheses x plus 10 be equal to 3 parentheses x minus 8 and solve. Remember, you distribute. So 2x plus 20 equals 3x minus 24. Move your like terms so they're on the same side. So we get x to be 44 for this first example. In this next example, notice how they are not corresponding. They're not alternate interior. They are not alternate exterior. They are C to C, right? If you rotate your page 90 degrees, you'll see that C, right? Those are consecutive angles and they have to add to 180. So you should be taking both angles, adding them up to equal 180. So combining like terms, we end up getting 108. Subtracting 108 from both sides. And then dividing by 4. And we get x equals 18. So this would be the consecutive angle converse. And then remember this other one would have been the alternate exterior angle converse. Okay? All right, so now we're going to do a proof. It says prove the alternate interior angle converse. So since we are proving the alternate interior angle converse, you cannot use that theorem or converse in the proof. Okay? So just like before, you always set up your proof. So in this proof, we're given that angle 4 is congruent to angle 5. So you can see in the picture, we've already put little marks at 4 and 5 since they're congruent. All right, so that's not really a clue. So when you don't have clues, you look at your picture and you look specifically for other angles that would be congruent. Now, again, we don't know if these lines are parallel. Our goal is to prove that they're parallel. Okay, so you can't use any of the other corresponding angles. You can't use any of that. Really, you can only use linear pair postulate and vertical angle theorem, which in this one, we want to use the vertical angle theorem because if we already have 4, we can say 4 is congruent to 1 using the vertical angle theorem. Okay, so since we've added another piece of information to our proof, then we want to look in our proof. So I would always zoom in at this part. Notice anything? Well, angle 4 is congruent to 5 and 1. So since the angle 4 is congruent to both 5 and 1, that must mean that 5 and 1 are congruent to each other. So we can say angle 5 is congruent to angle 1 using the transitive property. It's never going away. All right, so once you've used the transitive property, you want to look up at your proof. I'm going to erase these just to simplify this. If we know that 5 and 1 are congruent, what kind of angles are 5 and 1? Aren't they corresponding? And if corresponding angles are congruent, aren't the two lines parallel? So we can say G is parallel to H using the corresponding angle converse. Now in a proof, we will always be using the converse every single time we prove the lines parallel. So I want you to put a circle around the converse and draw an arrow to the parallel symbol, because that's going to help you remember that every time you're trying to prove lines are parallel, you need to use the converse as your reason. Okay, I promise you it will help you, so please circle that converse and draw the arrow to the parallel. I'm going to do it every time when we do one of these, and it will help you. All right, so let's try another one. This time we're going to prove the alternate exterior angle converse. Okay, again, since we're proving the alternate exterior angle converse, you're not allowed to use that theorem or converse in your proof. So nowhere over here on the right side should be AEA converse. All right, so setting up our proof, we were given that angle 5 is congruent to angle 8. So in our proof, or in our picture, we're actually going to mark off 5 and 8. Notice how they're alternate exterior angles, right? We're trying to prove the alternate exterior angle converse, so that's why we can't use that as a reason over here. Okay, so just like before, angle 5 is congruent to angle 8 is not a clue. So we're stuck, and when we're stuck, we look in our proof. Do you see how we have vertical angles? So I can use the fact that 5 is congruent to 8, or 5 is congruent to 6. Using the vertical angle theorem. There's no vertical angle converse, just so you know. All right, so you technically could also include that 8 is congruent to 7, right? Because technically 8 and 7 are vertical angles. But we're going to leave that for later. Since we already have this, we're just going to go with it. So they're both equal to 5. And since they're both equal to 5, then 8 and 6 must be congruent to each other. So angle 8 is congruent to angle 6 using the transitive property, right? So that's when you look at your picture. So again, I'm going to simplify this for you. I'm going to erase this. At least I'm trying to erase it. There we go. So looking at 8 and 6, are those alternate exterior angles? Nope. And we know they're congruent, right? So we can prove that the two lines are parallel. So I can say A is parallel to B. Now what type of angles are 6 and 8? Aren't they corresponding? So we're going to use the corresponding angle converse to prove that the two lines are parallel. And again, circle the word converse, draw your arrow, because every time you're trying to prove two lines are parallel, you're going to use the converse of whatever angles you proved are congruent. Or if it's C to C, you're going to have to prove that they're supplementary. All right, so in this next one, we're going to do a parallel line proof. So we're given some information. A is parallel to B and angle 2 is congruent to 3, and our goal is to prove that line C is parallel to line D. So set up your proof. All right, so the first thing it's giving us is that A and B are parallel to each other. 2 and 3, if you look at it, aren't really equal, so that kind of makes it difficult. Right, 2 and 3 don't have a relationship with parallel lines. It's not like they're corresponding angles or consecutive angles or alternate interior, alternate exterior. So this clue right now, that 2 is congruent to 3 is going to be, we're going to hold on to that for later because it's going to be important later. So right now, if you're looking at the lines A and B that I highlighted over, we have an option. We can either choose to use C as a transversal, and then we can use angles 1 and 3, which happen to be alternate interior angles, or we could use line D as our transversal. And then we've got C to C. See how we've got 2 and 4? If we use C to C, then we have to write down in our proof that the measurement of angle 2 plus the measurement of angle 4 equals 180. And that just makes our proof more difficult, right? If you think about the supplementary and complementary proofs that we had in the previous chapter, they were more difficult than the ones that are congruent. So when you're given the option, I always recommend just going with the ones that are congruent. So we're going to use C as the transversal for the parallel lines A and B. So if C is the transversal of A and A is parallel to B, 1 and 3 are congruent. So step 2, we can say angle 1 is congruent to angle 3 using the, and these are alternate interior angles. Now we're not using the alternate interior angle converse because we're not proving that the lines are parallel, right? Didn't we say angle 1 is congruent to angle 3? So that's actually from 2 days ago. That's the theorem. So you will always use the theorem when you're proving two angles congruent. You only use the converse when you're proving lines parallel. And is this proving lines parallel? No. Okay? So we should be using the theorem. So once we've done that, take a look. Do you see how we have angle 3 repeated? So we can use a transitive property just like before to say that angle 1 is congruent to angle 2. All right, so if I look at my picture now, right, the picture is the key. If I look at angle 1 and angle 2, do you see how they're both using this transversal A? Do you see how angle 1 is using angle C with angle, or line C with line A, and line D and line A are making angle 2? Aren't we trying to prove that C and D are parallel? So now if you focus on just the blue lines, aren't C and D parallel because 1 and 2 are congruent? So we can say that C is parallel to D using the, and then look at your blue angles. Look at angles 1 and 2. What kind of angles are those? Aren't they corresponding angles? So you can say that C is parallel to D using the corresponding angle converse. And once again, circle the converse, draw the line to point at the parallel lines. It really will help you, right? Here we had to use the theorem because we weren't proving they were parallel. We were proving that angles were congruent. So it's theorem when you're proving angles are congruent. It's converse when you're proving the lines are parallel. All right, so last thing for today is the transitive property of parallel lines. It basically says if two lines are parallel to the same line, then they're parallel to each other. So if you look at this example, it says if P is parallel to Q and Q is parallel to R, then P would be parallel to R. Right? You just cross off the stuff that's the same and then put what's left over together. Right? P and Q are parallel. And then Q and R were parallel. So technically, all three of them are parallel to each other. All right, so taking a look at this example, it says P is parallel to Q. And Q is parallel to R. Find measure 8 and explain your reasoning. So let's first pay attention only to these parallel lines and this transversal. So if we already know these are parallel, we could say that this angle is 115 using corresponding angle theorem. We already know they're parallel. We're not proving they're parallel. We're proving the angles are congruent using the theorem. And then let's pay attention to this now. If Q is parallel to R, using the same one, we can use the fact that this is 115 as well, using the corresponding angle theorem. And then if that angle is 118, can't we use the linear pair postulate to find out angle 8? So 180 minus 115 would be 65 degrees. So the measure of angle 8 equals 65 degrees. So we're technically using the transitive property, right? If P is parallel to Q and Q is parallel to R, then P is parallel to R. So you could technically just ignore Q. If P is parallel to R, then they're congruent using the corresponding angle theorem. All right, so that's it. Homework is going to be a worksheet, so go ahead and get started on it.